Hello, Mario. In this video, we're going to take a look at calculating the area of some irregularly shaped objects. So here we have an irregularly shaped object, the red line there, and the task here is to estimate the area of the red shape by counting squares. Each square is 1 metre by 1 metre, which is 1 square metre. So the first thing we do is identify the full squares. These are the entire square is contained within inside the shape. And I've coloured these ones green, and as you can see, I've numbered them consecutively, and they number 38. A few tricky words in this one. So there's 38 of those, so 38 times 1, 38 metres squared. Secondly, I've numbered the number of squares counted as a whole. So the magenta squares, although there's little tiny bits missing up, they're considered as whole squares, give or take. So certainly more than half. So I've counted those magenta ones, and there's 14 of those, so they'll count as 1 square metre, so that's given 14 square metres. Then I've looked at the cyan squares, and I've counted them as they're approximately half squares. So they're not real little tiny squares, but there's approximately half a square, around half a square in each one of those. So I've counted those consecutively, and labelled them consecutively, and there's 8 of those. Now I'm only going to count them as half a metre. So 8 times a half is 4, and then the estimated total area of the shape, when we add that up, is 56 square metres. Now this is only an estimate. There are a number of ways you could sort of interpret it or look at the squares. I mean, so you could look at each square if you wanted to and just estimate what percentage of the total area of the square was covered or uncovered, and then add all those up. There's various ways of doing it. So you could have, 0.1 of a square, 0.2, 0.5, 0.7, just a rough estimate. That might give you a slightly more accurate reading, but generally the way that I've done here is sort of fairly reasonable. And in this case we've got 56 square metres. So how you use the squares to estimate the area is totally up to you, and if you want to apply a bit more science to it, go ahead, not a problem. Now the area, as I drew up this little area here, I drew it up in AutoCAD, and where I was able to determine what the area was, and it was sort of a 56 metres squared. So I've come out pretty well this time, although that's not always the case. So with an estimation such as this, you might want to expect it to sort of be plus or minus 10%. I think it's probably reasonable, depending on what you want to use it for. I mean, obviously, if it needs to be more accurate than that, obviously, if each square metre is worth, thousands of dollars, say, be it in land or commercial area that you want to use, well, then you might want to get slightly more accurate measurements, or use slightly more accurate techniques. So with an expected accuracy of plus or minus 10% over 56 square metres, so that's roughly 5 or 6 square metres, sort of rounding up. So you would expect to get an answer somewhere between 50 square metres and 62 square metres. So quite a range there, but as I say, depends on what you're using it for, how accurate your answer needs to be. Obviously, if there's huge amounts of dollars involved in the area that you determine, well, you might want to be a bit more careful. Okay, so moving right ahead now, we're going to take a look at perimeter. So here we have the same shape, and this time we want to estimate the perimeter of the red shape below by counting squares. Again, each square is 1 metre by 1 metre. So what I've done here is just to count each full length through each square. So, and I've again numbered them consecutively, and I've got 1 through 29, so clearly I've got 29 metres. But you need to use some discretion as to where very small little bits of square might be involved, say for instance in this area here. But you do need to remember, like for instance here, say for instance, or here, that that the diagonals of the square would be around about 1.4 metres long. Okay, so when you're going across the square diagonally, that's about 1.4. So the little one there, by counting the little ones, you may compensate for that extra length by going across the square diagonally. So, but anyway, I've mine here. So you don't necessarily count every tiny little bit, but you just sort of keep an eye on things as you're going along, and perhaps add things up. Use a bit of discretion, as I say, as to what you do and don't count. But generally, you're just looking for 1 metre lengths of square. So I've estimated a total length 29 metres. Now, the actual value determined by AutoCAD, as I said previously, digitally, was 28.6 metres. So not too bad in this case here. Now, the expected accuracy, again, plus or minus 10%, 28.6, around about 2.8, 2.9 metres. I've gone for 2.8, around about 2.8 there. So you'd expect the value to be somewhere between 25.8 and 31.4. So somewhere in that region, somewhere between 25.8 and 28.6 would be greater than 25.8 and less than 31.4. Somewhere in that area. So yeah, pretty good. Alrighty. So, but is this the only way to do it? Well, no, it's not the only way to do it. There are other ways of calculating these areas and perimeters. And I've alluded to one of them in here, and that is, in fact, to scale a digital picture using software like AutoCAD and that. So it's very important that if you're doing it this way, that you get the correct scale, otherwise you can be out by large amounts. So it's important that you have the shape drawn correctly to scale, and then you can measure it in AutoCAD by using some of the functionality there, such as polylines and things, which will tell you the area of a shape and the perimeter distance around the outside of the shape. You could estimate the shape by using other shapes or combinations of other shapes. So you could maybe break it up into triangles and squares and trapeziums, or various combinations of those, and then work out the area of each one and add them all together. There are various techniques there. And indeed, as I've said previously, there's various techniques with the square counting as well, depending very much on the accuracy of the result, how important the result is, what's hanging on the result. So, for instance, if you were using the area to determine how much food, how much to feed out to some dairy cows or something like that, plus or minus 10% would be fine. But if you were using maybe the area to determine the lease of a bit of land in a rural situation, that would be fine. If, however, it was being used to determine the area in a very commercial situation where square metre rates might be in the thousands of dollars, it could be quite significant, a 10% error in that case. So you need to go to a more accurate method of measuring and determining the area. One sort of unique way that a lot of map makers used when they were splitting up large areas of land into lots of different little areas was to actually cut out the shape of the map and paper and weigh it accurately, and then compare that weight with a similar bit of paper of known area. And so they're able to, with some quite accurate chemical balances, actually work out areas that way. But It's beyond most of the average people, but nonetheless another method. There is also a thing called a planimeter, which is a mechanical device that you run round the outside of the shape, and it will determine the area with various calculations and things. And there are probably numerous other ways of measuring area and perimeter of these things, and you are now aware of a few of them, and some of the others, depending on where you go, what workplace you're in, what situations you have, will depend what you use. One way of working out the perimeter, of course, is to place a length of string around the perimeter of the shape, and then to obviously measure the length of the piece of string and straighten it out. So, all sorts of options and opportunities in that become available. So here you've got a few that you can use, and you may come up with some way better ones of your own. Cheers.